Good afternoon, students. Welcome back to chemistry class. In last class, we started the fourth unit, hydrogen. What about the position of hydrogen in the periodic table and isotopes of hydrogen we studied yesterday. Today, we are going to study about ortho and parahydrogen and preparation of hydrogen. The laboratory preparation only we are going to study. Okay, electrolysis method and laboratory preparation method we are going to study today. Okay, take your notes. All of you should take notes. Listen carefully. Very important. Ortho and parahydrogen. Ortho and parahydrogen. What do you mean by orthohydrogen? What do you mean by parahydrogen? Okay, listen. The hydrogen atom consists of a proton around which one electron revolves. We know about that. Hydrogen means one of the proton and one of the electron. Okay, this is the nuclei of the hydrogen atom. One proton and one electron. Okay. So hydrogen atom, the atomic hydrogen cannot exist in free state because only one electron present in the outermost orbit. Okay, so the hydrogen, it always try to exist in a molecular form. What is the molecular form of hydrogen? That is hydrogen, H2. Molecule hydrogen is a diatomic molecule. Diatomic molecule means two atoms. Okay, so the molecular hydrogen try to exist in the hydrogen try to exist in molecular form. Okay, H2 and another one hydrogen proton and one electron. Okay, understood? So the hydrogen atom contains of a proton around which one electron revolves. Okay, so here both the proton and the electron spin are about. Both the proton and the electron spin about an axis like a top. Okay. Till nowadays, we know that electrons revolve around the nucleus in a circular path. Okay. Now we know about that. Clearly we know about that electrons, the protons and neutrons. That is nucleus. Okay. What is nucleus means? Nucleus consists of protons and neutrons. Okay, so it is the nucleus, it is present at the center of the nucleus and electrons are revolve around the nucleus. We know about that. But protons also rotate its own axis. Proton in the nuclei. Okay, proton present in the nuclei also rotates its own axis. Okay, how Earth revolve around the sun, like that electrons revolve around the nucleus. Okay, and how the earth rotate itself, rotate its own axis, the proton, like that the proton in nucleus also rotate its own axis. Okay, understood? The proton also rotate its own axis. That is called the proton is spinning. Okay, the electron, both the proton and the electron spin about an axis like a top. Okay, clear? So here, what do you mean by ortho form of hydrogen and what do you mean by para form of hydrogen? Okay, here, when molecular hydrogen is formed, when molecular hydrogen is formed, the spins of two hydrogen nuclei, can be in same direction or in the opposite direction. When molecular hydrogen formed, this is the molecular hydrogen. When the molecular hydrogen formed, the spins of two hydrogen, this is the nuclei of hydrogen, this is the electron. The electron revolve around the nucleus. Okay, so this when molecular hydrogen formed, the spins of two hydrogen nuclei can be in same direction. This is the same direction clockwise, okay, say this like, okay, same direction or in the opposite direction, okay, this is the same direction and or in the opposite, this is the opposite direction. Okay, so spinning takes place in same whether it is the same direction or in opposite direction. Okay, here what do you mean by orthohydrogen? What do you mean by parahydrogen? Ortho means the protons in a nuclei spin in same direction. Okay, when the two, we are taking the one molecule hydrogen. In the molecule of hydrogen, protons of the two nuclei of the hydrogen spin in same direction, that is called orthohydrogen. Okay, understood? The protons of the nuclei, the proton in the nuclei of the hydrogen spin in opposite direction, that is called parahydrogen. Okay, so the spins which are parallel, this is the parallel, the spin of the proton in the nuclei of the hydrogen to hydrogen atom, it is in parallel means orthohydrogen. Okay, the spins or the spins which are in anti-parallel, okay, spinning of proton in the nuclei in anti-parallel direction, anti-parallel or in opposite direction. One proton spinning like this way and another one proton spinning like this way. This is the anti-parallel. This is the anti-parallel. Okay, opposite direction means this is the parahydrogen. Okay, so what do you mean by orthohydrogen? Orthohydrogen means hydrogen molecule in which the spins of both the nuclei are in the same direction. Hydrogen molecule in which the spins of both the nuclei are in the same direction means orthohydrogen. Parahydrogen means hydrogen molecule in which the spins of both the nuclei are in the opposite direction. Okay, hydrogen molecule in which the spins of both the nuclei are in the opposite direction means parahydrogen. Understood? Okay, can you differentiate ortho and parahydrogen? This is the two isomeric form of hydrogen. Okay, understood? And then we are going to study about the stability of the which isomer of hydrogen is stable. Okay, whether orthohydrogen is stable or parahydrogen is stable. Now we are going to study. Okay, the stability of ortho and parahydrogen. Here at room temperature, 75% ortho form stable. Okay, orthohydrogen is stable. At room temperature, 25% para form is stable. Okay, so orthohydrogen only stable 75%. Okay, among 100%, 75% is ortho form is stable. Orthohydrogen is stable at room temperature. Okay, only 25% parahydrogen only stable, 25% only. But temperature will be vary. The parahydrogen try to get the stable form. Okay, that is ortho form. Okay, try to get the ortho form. Understood? So here what is the stable form? Ortho form only stable. Okay, more than 75% orthohydrogen only stable, but parahydrogen it did not stable. Okay, so how we can convert the parahydrogen into orthohydrogen? Okay, conversion of parahydrogen into orthohydrogen. How will you convert para hydrogen into ortho hydrogen. Okay, first point, all of you note this. This is very, very important. This is your assignment also. This is today assignment, this. Okay, all of you note this. By treatment with catalyst like platinum or iron. Okay, how will you convert para form into ortho form? First upon, we can applying any catalyst. Okay, by we can applying any catalyst. We can applying any catalyst. That is which catalyst? Platinum or iron catalyst. Any one catalyst, we can convert the ortho form into para form into ortho form. Okay, and secondly, second point, by passing an electric discharge. By passing an electric discharge, we can convert the, already I told you, when temperature will be changed, the para form can be converted to ortho form. Okay, so when we are applying any electrical discharge, we can convert the para form into ortho form. Okay, what is the third point? By heating to 800 degrees Celsius or more. Okay, at room temperature, para hydrogen, it is the not stable. Okay, but we are heating the para form of hydrogen at 800 degrees Celsius or more. We can get the ortho form of hydrogen, stable form hydrogen molecule we can get. Okay, or otherwise, by mixing with the paramagnetic molecules like oxygen, nitrogen monoxide and nitrogen dioxide. Okay, when we are mixing any paramagnetic molecules, we can convert the para form into ortho form. And another one point, by mixing with nascent hydrogen or atomic hydrogen. Okay, nascent hydrogen or atomic hydrogen. What do you mean by nascent hydrogen? Means one of the purest form of hydrogen. Atomic hydrogen means when hydrogen molecule dissociate to, we get the hydrogen, two hydrogen atoms. That is the atomic hydrogen. Nascent hydrogen means the hydrogen, the purest form of hydrogen obtained by the chemical reaction. Any chemical reaction, metals, two or more metal react with each other, we get the purest form of hydrogen. That is the nascent hydrogen. By mixing the para form of hydrogen with nascent hydrogen or atomic hydrogen, we get the ortho form of hydrogen, stable form of hydrogen we get. Okay, understood? These are about the conversion of para form into ortho form. And then we are going to study about differences between ortho and para hydrogen. What are the differences between ortho and para hydrogen? Very, very important. All of you note this difference. Okay, very, very important. What are the differences between ortho and para hydrogen? What is the first point? Both the nuclei in the same direction. Both the nuclei. Okay, the two ortho hydrogen means one of the hydrogen molecule, both the hydrogen atoms, both the nuclei of the hydrogen atom are in the same direction. Okay, both the nuclei of the hydrogen spin in same direction. That is called the ortho hydrogen. Para hydrogen means both the nuclei of the two hydrogen atoms are spin in opposite direction. Spin in opposite direction. That is called the para hydrogen. Okay, and the second point, we know the ortho hydrogen stable 75% stable at room temperature. Okay, but para hydrogen 25% stable at room temperature. Okay, and what is the third point? What is the third point? The melting point. The melting point of ortho hydrogen 13.995 Kelvin. Para hydrogen 13.83 Kelvin. And fourth point, boiling point of the ortho hydrogen, that is 20.39 Kelvin. Boiling point of the para hydrogen 20.26 Kelvin. Okay, and what is the fifth point? The magnetic moment. Magnetic moment is twice that of the proton. Okay, twice means for example, I am taking the ortho hydrogen. The proton of the two nuclei spin in same direction. Same direction means what is the magnetic moment? Magnetic spin here plus half. Okay, here also it is same direction means plus half. Okay, so what is the magnetic moment? This is the twice of the proton. Okay, so this is half, this is half, plus half, we get the 1. What is the magnetic moment of the ortho hydrogen means 1. Okay, that is the twice of a proton. But here para hydrogen means zero magnetic moment. Zero magnetic moment means the proton of the nuclei of the para hydrogen, it is spin in opposite direction. Opposite direction means this is the plus half. Okay, what is the magnetic spin here? Plus half. This is minus half. Okay, plus half and plus half. We are adding the plus half and minus half, we get the 0. Okay, so the magnetic moment of the para hydrogen will be 0. Okay, so what is the difference between ortho and para hydrogen? Ortho hydrogen, both the nuclei in a spin in same direction, and para hydrogen, both the nuclei spin in opposite direction. Okay, and second point, 75% of the ortho hydrogen is stable at room temperature. Para hydrogen, 25% of the para hydrogen, it is stable at room temperature. What is the melting point? 13.95 Kelvin. Boiling point, the para hydrogen melting point 13.83 Kelvin. Then what is the ortho hydrogen boiling point? 20.39 Kelvin. Para hydrogen, what is the boiling point? 20.26 Kelvin. After that last the fifth one, the magnetic moment, it is twice that of a proton. Ortho hydrogen magnetic moment twice that of a proton, but para hydrogen zero magnetic moment. Okay, these are about the differences between ortho and para hydrogen. Now, preparation of hydrogen. Hydrogen is prepared by electrolysis method. We are going to study about hydrogen prepared by the electrolysis. Okay, electrolysis means, what do you mean by electrolysis? The decomposition of electrolyte by passing current, that is called electrolysis. Okay, when we are passing current through the electrolyte, the electrolyte will be decomposed, that is called electrolysis. Okay, here for the electrolysis, 3 substances we need. What are the 3 substances? First one, electrolyte. We need electrolyte and anode and cathode. Okay, anode and cathode. Electrolyte, for electrolyte we are taking water with a little alkali. Okay, the water is made conductor by the little alkali, by adding little alkali, or any other electrolyte can be using. We can use what are the electrolytes? Sodium hydroxide or potassium hydroxide, we can also use here, but we are taking here water as the electrolyte. Okay, water with a little amount of alkali to made conducting property. Okay, and anode, which one is the anode? Here we are taking nickel. Nickel is used as the anode. 2 electrodes. What are the 2 electrodes? Anode and cathode. As anode, we are taking, at the anode we are taking the nickel. At the cathode we are taking iron. Okay, nickel electrode we are taking at the anode, and the iron electrode we taken as the cathode. Okay, so when we are connecting these 2 electrodes in a battery, current is passed through the electrolyte. Okay, this is the electrode, 2 electrolyte, this is anode, and this is the cathode. Okay, these 2 electrodes are separated by this membrane, separated by one of the asbestos diagram cell. There is one of the membrane, and when we are passed through the current through the electrolyte using the electrodes, at the anode the oxygen gas is evolved. Okay, at the cathode we get the hydrogen. Okay, hydrogen we get at the cathode. Understood? So here 2 types of reaction we are taking, forming here. What are the 2 types of reaction? Anodic reaction and cathodic reaction. And which of the reactions that takes place here? There are two types of reactions that takes place here: oxidation and reduction. Okay, oxidation and reduction. At anode undergoes oxidation and cathode undergoes reduction. Okay, so oxidation means loss of electron, reduction means gain of electrons. Okay, so here what is the anodic reaction takes place here? We know this is the anode. Anode consists of one of the electrodes, nickel electrode, and what is the electrolyte we are using here? Water and mixed with alkali. We are taking sodium hydroxide alkali. When we are passing current through this electrolyte, there is a water mixed with NaOH. Okay, so when this electrolyte is decomposed, to form Na plus and OH minus ions. Okay, and then this OH minus ions, okay, further decomposed to form to remove the oxygen gas, to release the oxygen gas as the byproduct. Okay, OH minus ions, okay, it will form the oxygen gas. OH minus form two molecules of OH minus to form oxygen gas. Also here also having water, also having or hydrogen, more hydrogen here having as the water molecule. Okay, oxygen gas is evolved at the electrode. Okay, this electrode at the anode, oxygen gas is evolved. Okay, by balance, how we are balance the chemical reaction here? How much amount of oxygen, how much oxygen atoms are having? 2 plus 1 3, but here only 2 oxygen atom, only 2 oxygen atom is having here, but here 3 oxygen atom here having. So we are taking here half oxygen. Okay, half oxygen molecule, half oxygen molecule removed, half oxygen molecule is removed, and then hydrogen. How much hydrogen atom? 2 hydrogen atom. Here also 2 hydrogen atom. Oxygen here 2 oxygen atom. Here how much oxygen atom? 1 and another 1. Half plus half. Okay, half oxygen molecule means half oxygen atom plus half oxygen atom. We get 1 oxygen, 1 atom of oxygen. Okay, 1 oxygen, but this oxygen, it does not exist in free state. Okay, so it is combined state, it is exist in molecule state. Okay, so half oxygen atom will be, half oxygen gases will be released at the anode. Okay, and here on minus also having minus exhibit. Minus means this is electrons. Okay, minus charge indicates the electrons. How many electrons are having? 2 minus charge having. So 2 electrons are okay, evaporate here. Understood? So oxidation is loss of electron. 2 electrons are lost here by the 2 OH minus ions. Okay, and this is the anodic reaction. What is the cathodic reaction? At the cathode, when at anode, you know, at anode oxidation takes place. Oxidation is loss of electron. Okay, so by the alkali, high oxygen gas is evolved at the anode, and the alkali means OH minus ion, it release the 2 electrons, 2 ions, electrons. Okay, these electrons, these ions, it enter into the cathode. Okay, it enter in the cathode. When it entering the cathode, here also having water. Okay, water electrolyte. This water molecule accept this electron. Okay, accept this electron, and also it release the hydrogen gas. Okay, so here water molecule having already, so this water molecule accept these electrons, because cathode means reduction. Cathode means at anode oxidation takes place, at cathode reduction takes place. Reduction means gain of electron. Reduction means gain of electron. Okay, when At anode, the OH minus ion, that is base, it release 2 electrons. These electrons enter into the cathodic electrolyte. The water electrolyte, it accept the water molecule present in the cathode. It accept these 2 electrons and to form hydrogen gas. Okay, hydrogen gas. Okay, to produce the hydrogen. Okay, H2O plus 2 electron. It form 2 OH minus and hydrogen gas. Okay, understood? This is the 2 reactions. Okay, a anodic reaction and cathodic reaction. And overall reaction, what is the overall reaction takes place here? Here 2 OH minus having this OH minus and this OH minus, opposite, the same species having, we can cancelling 2 OH minus 2 OH cancel, and one H2O and 1 H2O cancel here, 1 H2O extra having here, and this 2 electrons and this 2 electron we are cancel. Okay, so overall reaction here, one of the hydrogen molecule 1 H2O gives hydrogen plus of oxygen plus. Okay, that's all. Okay, this is the overall reaction. So when electrolysis of water molecule, we get the hydrogen gas and oxygen gas. Okay, oxygen gas evaporate as the byproduct and we can prepare the hydrogen. Okay, understood? This is the preparation method of hydrogen by the electrolysis process. But this process, it is not economical for large scale production. Okay, because of this we can use alternate preparation method. Okay, another one method we are taking here laboratory preparation method. In this method, hydrogen is conveniently prepared in laboratory by the reaction of metals such as zinc, iron, tin with dilute acid. Okay, here this is one of the apparatus, round bottom flask. What is this? A round bottom flask, and one of the cork, this one of the cork, and with the one of the, this is one of the glass tube. By the glass tube we are entering the hydrochloric acid or sulfuric acid poured in a round bottom flask, and already we put the zinc dust, zinc metal. Okay, zinc dust. This zinc dust we are taken here the round bottom flask, and dilute hydrochloric acid also we are poured in the round bottom flask. When hydrochloric acid reacts with the zinc, one of the displacement reaction takes place here. The zinc displaces the hydrogen from the hydrochloric acid, so it forms the zinc chloride. Zinc chloride, it is left in this round bottom flask, and hydrogen gas is evolved out. Okay, this hydrogen gas is collected in a reservoir. This one of the reservoir, hydrogen gas may be we can collect. Okay, through the bubbles, hydrogen gas we can feel the hydrogen gas. We can see the hydrogen gas as the bubble. Okay, bubbles forming. We are collecting in a reservoir. This is the preparation of hydrogen in laboratory. Okay, here what is the equation having here? The zinc metal, it reacts with hydrochloric acid to form zinc chloride and hydrogen gas. Okay, how we can balance the equation? Here zinc, how much zinc? Only one zinc having here also only one zinc. Chlorine, but here 2 chlorine atoms, so we can make here 2. Okay, hydrogen, 2 hydrogen, 2 hydrogen. Okay, so equation is balanced. This is about the laboratory preparation method. Clear? Okay, students, today your assignment, 2 assignment I will give today. Question number 1. How do you convert para-hydrogen into ortho-hydrogen? How do you convert para-hydrogen into ortho-hydrogen? And second question, explain preparation of hydrogen using electrolysis. Explain preparation of hydrogen using electrolysis. Okay, these two questions you should study. Okay, and write and send me through my WhatsApp number. If you are having book, take your book now. Students, take page number 103. In your book, page number 103, take now. How will you prepare hydrogen using electrolysis? Explain the preparation of hydrogen using electrolysis. The preparation of hydrogen heading, write the heading electrolysis. Okay, electrolysis, and to mark the question, high purity hydrogen is obtained by the electrolysis of water containing traces of acid or alkali, or the electrolysis of aqueous solution of sodium hydroxide or potassium hydroxide using a nickel anode and iron cathode. Okay, which one is the anode here? Nickel is the anode and the iron is the cathode. Which one is the electrolyte we are using here? Water containing traces of acid or alkali. Okay, and however, this process is not economical for large scale production. Two reactions are having here: a anodic reaction, cathodic reaction. Okay, at anode oxidation takes place, at the cathode reduction takes place. Okay, and to overall reaction we got. Okay, oxidation is loss of electron. For anodic reaction, lost the 2 electrons. At the cathodic reaction, it accept these 2 electron. Okay, here 2 OH minus ion in the NaOH. Okay, we are taking, which one is the electrolyte we are using here? Water containing traces of acid or alkali. We are using here alkali, water plus alkali. Okay, water plus alkali. So in alkali having OH minus ion, this OH minus ion, it lost 2 electrons and it liberates the oxygen gas. Okay, in the water molecule. Okay, so 2 OH minus gives H2O plus half oxygen plus 2 electrons. Okay, and at the cathode, this at the cathode they are also having water plus alkali. So this water molecule present at the cathode, it accept these 2 electrons. Okay, so these 2 electrons enter into the cathode. So the cathode having water molecule, this water molecule in cathode accept these 2 electrons to form OH minus ions and also release the hydrogen gas. Okay, so overall reaction, when we are cancelling the same terms, 2 OH minus cancel and 2 OH minus cancel. Here 1 water molecule and 1 water molecule cancel. Here 2 electrons and 2 electrons cancel. So one of the water molecule are only having here. So this 1 water H2O gives this H2 plus half O2. Okay, this is the about the preparation of hydrogen using electrolysis. Okay. And next question, how do you convert the para-hydrogen to ortho-hydrogen? Okay, page number 102, the last paragraph, last 4th line onwards, we have to mark. The para form can be catalytically transformed into ortho form using platinum or iron. Alternatively, it can also be converted by passing an electric discharge heating above 800 degrees Celsius and mixing with paramagnetic molecules such as oxygen, nitrous oxide, nitrogen dioxide, or with nascent or atomic hydrogen. Okay, these 4 lines have to mark. The para form can be catalytically transformed into ortho form using platinum or iron. Alternatively, it can also be converted by passing an electric discharge heating above 800 degrees Celsius and mixing with paramagnetic molecules such as oxygen and nitrous oxide, nitrogen dioxide or with nascent or atomic hydrogen. Okay, up to here I have to mark. Okay, students should study and write and write the assignment and send me through my WhatsApp number. Don't forget that. Don't take it easy. Okay, thank you all of you.